Hi everyone, and welcome to another video of the SAFI webinar series. In this video, we're going to have an overview of one-way members. Tension or compression only members are commonly used in steel buildings when modeling brace frames that resist lateral loads. They also can be used in modeling cables. To define a tension or compression only member, the user needs to edit the member attributes and the member analysis parameters. By default, the program considers that a member has a tensile and compressive stiffness without force limits. The available behaviors are normal, tension only, compression only, limited compression, and limited tension. In the program, by default, all the members act in tension and in compression. When a member is defined as tension only, if it becomes in compression, it will be deactivated. A member that is defined as compression only acts in compression only, and if it becomes in tension, it will be deactivated. If the selected behavior is limited compression or tension, the allowed force must be specified. It is possible to specify this limit by specifying a fixed value or a ratio of the yield stress of the material. Depending on the chosen option, the maximum force or the ratio of the maximal stress must be specified. When a one-way member is deactivated, it retains its bending and torsion stiffness. Its axial stiffness is reduced by the residual stiffness ratio. The default value specified in the analysis parameter can be customized for specific elements. To customize this value for specific elements, we need to edit the attributes of a member, then we specify in the member analysis parameters dialog box the residual stiffness. When a member is deactivated, the internal axial forces in the member may be different than the intended allowed axial forces. In this case, the Fmax due to the residual stiffness. Without further ado, let's start our demo. To define a tension or compression only member, the user needs to edit the attributes of the member. In the member attributes dialog box, the user needs to modify the member analysis parameter. By default, all members act in tension and compression. To specify a tension only or compression only member, the user needs to specify the member behavior. When a member is defined as a one-way element, graphically, it will be displayed with a discontinuous green or blue line to highlight the specific behavior of these members. Let's run the analysis of this model. In the analysis dialog box, there is a checkbox where the user can enable one-way elements in the model. So, when this box is checked, the software will take into account the one-way behavior of the elements and the analysis will be an iterative analysis. In this example, we have a frame with two tension-only members. When we run the analysis, the user has the option to deactivate one-way elements by unchecking this box. When we run the analysis, this warning dialog box reminds the user that there are one-way elements in the model. We go ahead and we click Yes. We display the graphical results and we check the axial force Fx. So in this model, we can see that the diagonal is under compression and this diagonal is under tension. Now let's run the analysis again, but this time we will enable the one-way element. This time, we see that this diagonal is deactivated and we can see the red box with the X inside it appears. We can see the axial force is almost zero. The axial frame behavior depends on whether or not the tension-compression limits are exceeded at the end of the case. So, when a member is deactivated, during the analysis, we multiply the full axial stiffness by this factor, which is the ratio of residual stiffness. So, we replace the axial frame behavior with a sufficiently soft spring, which simulates a zero stiffness. By default, this value is 1 exponential minus 6, but the user can edit this value if the model isn't stable. If there are difficulties for the analysis to converge, When we have tension-only members, the user can increase the value of the ratio of the residual stiffness, which helps for convergence. For this example, if we focus on the number of iterations that the software needed to achieve the convergence, I specified a residual stiffness of 1 exponent minus 6, which gave a total number of 6 iterations. Let's see when we specify a value for the residual stiffness equal to 0. In this case, we see that the number of iterations increased by a lot, and the total number of iterations is now equal to 16. This parameter has a direct influence on the rate of convergence. Let's do an example, and we will put a value of 1 exponent minus 3. We see that the number of iterations are lower. However, we can see that a compressive force appears in the member that is deactivated. Let's set the value to the default value. We can also specify the behavior of the member as tension only, but we allow some compressive force. In this case, we specify limited compression, and we have two options how to specify the allowed force. The first one is a fixed value, so in this case, we specify the maximum compressive force that we allow. Let's put 1 kilonewton here, and we click OK. Then we run the analysis. This diagonal was deactivated when the axial compression force limit, 1 kilonewton, was attained. Another way to specify the allowed force is by specifying a ratio of the maximum stress. Let's say we specify a ratio, for example, 2% or 0.02. This ratio will be multiplied by the maximum stress to calculate the allowed force. That's it for this video. Thank you for watching, and catch you in another one of our webinar series videos.